This is unbelievable that you can transmit voltage, temperature, or any data up to 13 miles or 20 kilometers. I've just done that and I tested it. We were able to receive signal from a solar panel or from a battery. Hi, welcome to Product Review by Robojax. In this video we are going to test the Heltec LoRa 32 version 3 module. We're going to combine it with a package from Meshnology, which allows you to put 3000 mAh battery for longer operation time and also for longer transmission and reception for both. And I've added a high gain antenna to increase the range. We're going to test it to see how far we can transmit the voltage. This voltage can be 10 volts, 20 volts, even 100 volts or less or more. You can set it using two resistors and monitor your solar panel, battery, whatever you have. This is just for transmission or reception, but we can also have a trigger because this is a full microcontroller where you can program it to take action based on voltage. For example, if the voltage drops below certain value, take some action, do something, or if it is above certain value, do something. This video is part of a 4-video series on Wi-Fi LoRa 32 version 3. In the first video, we learn how to send temperature wirelessly for free over LoRa band up to 13 miles or 20 kilometers. In the second video, we learn how to read up to 150 volts DC and transmit it to 13 miles or up to 20 kilometers for free over LoRa. In the third video, we learn how to turn on and off a relay module remotely over LoRa band at 13 miles or 20 kilometers for free. In the fourth project, we monitor a door using a Hall sensor and LoRa module over 13 miles or 20 kilometers for free. Link to those videos are below this video in the description. The code that I'm providing will allow you to calculate the resistor for any voltage that you want. It will also give you the maximum voltage that you can measure with this. You just need two resistors. I'm going to show you the wiring and how to set this up, and I'm going to do the test. This is a Meshnology case with 3000 milliampere hour battery for this LoRa 32 ESP32 module inside it. You can carry it easily like this. For example, this is now showing the voltage, and this is another case, the same thing, but I've used longer, higher gain antenna, and I've put these wires so I can connect external solar panel or whatever I want to measure, or the battery. This is a wire, so this is transmitting the voltage and this is receiving it, and I'm going to show you all the code, every step with a setup, wiring, and you just need two resistors. To be able to measure up to 100 volts. So what is LoRa? LoRa is a long-range data communication. You do not need any license. You don't need to pay any fee. And the frequency in the United States, US and Canada and Mexico is 902 to 928 megahertz. So this is the Heltec Wi-Fi LoRa 32 version 3 module, and it is integrated with LoRa, Wi-Fi, and Bluetooth. When you purchase N32 from Meshnology, you get a package like this with two buttons and screws, so you can close this up, and it has space for the battery like this, and you can place the microcontroller, the LoRa 32, and close it so it will be protected and ready to use. And in our case, in this video, this is the package where this microcontroller is inside it, and 3000 milliampere from Meshnology is also inside it. I will provide you the link. You can purchase the casing and you can purchase the battery, or combine with all of these. There are different combinations available you can purchase. I use this green casing for our transmitter, where I'm going to connect it to the battery and measure the voltage of the battery, and this will transmit the voltage that it reads. Then I'm going to use the red case for the receiver, so this will receive the signal. The transmitter is transmitting the signal, the voltage, and the receiver is receiving it. To increase the range for transmission and reception, we can use high gain antenna, which is sold separately. The antenna, these are the size of antenna, so this is the antenna size and angle it can be bent. The link to purchase it is below the video in the description. The product is from Meshnology. When you come to meshnology.com, I've reviewed for this N30, but in this video we're going to do the review of this N32 series. You can buy it with a battery, with an antenna, with all these packages. The link will be provided. You can purchase it from Meshnology.com or from Amazon. The links will be provided. You can buy the package. You can buy a package with a microcontroller and LoRa and 3000 mAh battery, extra antenna, and the shell. You can get the red one, 2 package, 1 package, whichever package you prefer. The links will be provided. You can purchase the package green, red from Amazon, or with a battery. Any package you want, 1 or 2 packages are all available. The links will be in the description below this video. Let's have a look at the case. We see from these 2 buttons and this is the package of 2 batteries I purchased. This is a package from Amazon. It comes with a charger, and each battery is 3000 mAh. 1 cell. This is 3.7 volts and 11.11 watt hour. The module first connect the cable that comes with the module, and if I turn it around you see it. Then we will insert remove the nut, connector here. This is inserted fully and you have that much room out. Attach this piece of ring. Let's see how much room we have. Yeah, so insert the spring washer. round and squared holes, the same as these two. So round will go with the round. Use these two screws to attach them at these corners. Connect the antenna, because without the antenna, do not connect the battery. Our receiver is now packed and ready. Let's test the cable connector to see if it charges. Now there is a problem. If you want to disconnect the battery, the power is already on. You cannot do that. It might damage the transmitter. So what you do is open everything, disconnect the battery, and then remove the antenna. Otherwise, the LoRa module might get damaged. It's amazing quality. Here I'm going to connect the create resistors like this, R2. One side is connected to GPIO4, the other side is connected to the ground. Ground is connected to the negative of the battery. From R2 I'm getting R1, connecting it to the battery. Here is the formula for voltage across R2. V battery multiplied by R2 over R1 plus R2. If you want to rearrange and get the voltage for the battery, here is the formula. In our example, we are using 3.2 kilo ohm resistor for R2. For any voltage that you want to calculate R1, here is the formula. Just plug in your battery voltage, whether it's 24 volts, 48 volts, or 100 volts. This formula will work when R2 is a fixed value. And here is the wiring, how I've connected it. These two wires are from my power supply or battery. This is positive and this is negative. This is R1 and this is R2. From ground, this wire goes to ground. Across this resistor R2, I have a wire connected to pin 7. I've connected this wire, one wire to the ground, the other wire is connected to pin 4. So I'm going to connect the sensor wire. Also, I've created this hole the same way. Just use this. because it's layers of 3D printed. When you cut it, it clears very easily. And just cutting some room for the wire. I think that's enough. So now, after putting all the wires, let's put this in the box. These two wires are outside the box, so I can connect and disconnect the power. This connector to connect it and leave this outside. Now we can put the Now what I have here is this is connected to pin 4 and ground. So red is pin 4 and ground for reading voltage, and this is my battery. Now because this was very tiny and possible to make mistake, I created this connector, female. And this way I'm going to connect and turn this on. So now this is connected and my transmitter is ready. And anytime I need to turn it off, simply disconnect this large connector. And here, this is my black wire. I've soldered 3.3 kilo ohm, and here, and it's extending. I'm going to connect the 3.3 kilo ohm to the positive here. 3.3 kilo ohm is attached to the positive and negative. Red is longer and this side is shorter, the black. Now this is 39 kilo ohm. I'm gonna solder it in here. And here 39 kilo ohm is ready. And here the wire is ready to go. In order to work with Heltec WiFi LoRa 32 board, you need to install certain software on your Arduino IDE. First, we need to install the ESP32 boards, which is needed for any ESP32 board. Open your Arduino IDE. You can get it from arduino.cc. This is a free software. Go click here, boards, and then type ESP32. Here it says ESP32 by Espressif, and you will see here install button like that. Click on the install and that will be done. Then we need to install certain software for Heltec. First we will install ESP32 package. I will provide you this URL here, the JSON URL, which you can get it from Heltec documentation page under the ESP32 series. You right click and copy it. I will provide you the link. On Arduino IDE, click File, Preferences. This area is for additional boards. Click to open it so we can see there is nothing. If you see another line, just at the end of the line, click and go down, and then right click and paste. And click OK, and click OK. Wait for this to complete. Click on boards and type Heltec ESP32. You will see it here, and this button would be install. Click on it to install it. Then we need to install ESP32 extended library from Heltec. Now click on library. This was board and this is library. Click on it and type Heltec ESP32. And you will see here it says Heltec ESP32 dev boards. You see it says remove. If you have not installed it, you will see install button. Click and install it. Then we need Adafruit GFX library for the display. Come here, click on library and type Adafruit GFX library, and here the first one, Adafruit GFX library. Click install. It says it needs dependencies. Click install all. Wait for this to complete. Then we need to install the Robojax Heltec LoRa 32 zip library. This is needed for OLED and reading voltage. I will provide you the link from the description. Download and save that .zip file in your computer somewhere. Then click on Sketch, include library, add .zip library. Browse to where you saved it, find it, click select, and then click open. All the libraries and files that were needed have been installed. To check if the Robojax Heltec library have been installed, click on File, Example, scroll down until you see Robojax Heltec LoRa 32, and these files are there. Make sure the board is selected. If not, click here and select board and type here V3. You will see Heltec LoRa WiFi LoRa 32 V3. You see another kit is there. This says without LoRa, so select that, and then you should see the port. Select and click OK. Now let's open the code for the transmitter. click on File, Examples, scroll down to Robojax Heltec LoRa 32 and select any voltage TX secure. Set the pin that you want to read the voltage from, and this is the R1 39 kilo ohm. I used a multimeter and my multimeter showed this value, and then for R2 I got this value. R1 and R2 are in series like that, connected to the ground, so we are reading the voltage across R2, which is ground, and this side is connected to pin 4 in our lesson. This is a calibration factor where you can change it if your reading is a little off. Slowly change this number to 8 and then maybe add less or more until it's fixed. If you don't want to calibrate, just set this to 1. These are the texts that are displayed on the screen, and this is the security key for transmitting and receiving. We set our operating frequency, and here this is the power, which can be set from 2 to 20. For lab operation, set it to 2. The rest we don't need any setup. If you want to print debugging values on the screen, set this to true, otherwise set it to false. Board have been selected. Click on this button to upload the code to your board. If you have installed all libraries properly, this should not get any error, and the code will be uploaded successfully. Now let's open the receiver code. Click on File, Examples, go to Robojax Heltec, LoRa 32, and select any voltage RX secure. This is our code. If you want to enable debugging, set this to true. This is the text that is shown on the screen, and this is our security key for transmitter and receiver, and it must be the same. Here we are setting the frequency for our module. It must match with the transmitter. This TX power does not matter because within the code we are not using the transmitter. The rest does not need any adjustment. Here the board is receiving the voltage from the transmitter. However, this code needs a little adjustment. For example, if the transmitter is off, this will still show some value, so you have to reset it to see 0. I'm going to update the code. Watch out for the updates on my website. I've connected my external power to this point. This is R1, which is 39 kilo ohm, and this is R2, which is 3.3 kilo ohm. And we are reading the voltage across it, connected to pin 4 and ground. I've also connected a voltmeter so we can see the voltage and compare. I'm turning on my power supply. Now we are reading 28.88 and 28.87. I'm reducing the voltage. So it says 15 and then 14.9. Increasing it like 20 volts. And increasing it 30.6, this is also 5.9, very accurate. So this device is now transmitting, and we see the voltage, and we see on this corner TX. that means it's a transmitter, so you know it. Same board have been inserted here as I shown you before, and the battery, 3000 milliampere hour battery, and I've used this high gain antenna. The original package comes with this antenna. And this is another module, which is the receiver. This has been programmed as a receiver, which I'm going to explain now. Now, this is transmitting it, and I'm going to explain the receiver code, but you can see the voltage that is being transmitted, that voltage on the screen here. You will see it on the transmitter, and the receiver is receiving it. If you want to take some action based on amount of voltage, this variable, which is defined here at the top of the code, this is our voltage, which is a float value. Come inside the loop, and let's say you want to monitor something. If voltage is greater than 24.6, then do something. And so your action will be between these two curly parentheses, so that is called an action. You can do here turning on a relay, turning on the buzzer, fan, whatever, or smaller value. Now, to get started with the range test, I'm setting this power to 20. When I work here in the lab, it will be 2 because we don't need, that's the lowest. And I can go 21, but I'm going with 20 to test it. For the transmitter code, you must select your security key, which must matches with your receiver. You use the same code, you can change it, and this is the frequency that we set. So these two must match, and then set the power that you want. Here, the test is performed in this area on the lake because there is no obstacle on the path, and it's direct line of sight. We place our transmitter here, and it's almost about 10 meters above the water level. And as you can see, there is no obstacle on the path because we avoided all this, and it's about 13.04 mile or 20.98 kilometers, which is almost 21 kilometers. Let me show you my setup for range test. I've placed here a camera. Transmitter is installed on a tripod, and it's connected via these wires down to the battery, where we can reach up to 30 volts of the voltage. I've set this up by the lake, and we are transmitting it about 5 to 10 miles or even more. I'm going to see how far this can transmit. We're going to transmit the signal on the other side, and we're going to see the voltage that's being transmitted, receiving it on this receiver, and I'm going to show you on the Google map to see how far we are. I've left the transmitter there and then walking towards my car to drive to the further destination so we can receive the signal. I'm 13 miles, which is about 20 kilometers away from the transmitter. Here my map is showing it. I hope you can see it because it's a bright sun, and the voltage is now on the screen. So I've called already my friend on the other side. So I'm gonna ask my friend to change the voltage. Please change the voltage.
Okay.
Okay, so as you can see now, we see about 9.71 volt and 13 miles. Amazing. This is unbelievable. So we are 20 kilometers away from that direction where the antenna is pointing, and we are receiving signal. Thank you for watching a tutorial from Robojax. If you learned something and found this useful, please thumb up. If you have comment or question, please post it in the comment section below. I try to answer and reply. And to get updates of my upcoming videos, make sure to subscribe.